Okay, good afternoon, everyone. It's my pleasure to introduce Justin Cheng. And without further ado, please take it away.
Thank you. Hi, everyone. Thanks for taking the time to come today. I'm going to be talking about antisocial computing. So social media has brought us closer together online. It provides social support and can improve our mood. It's also been used for social good, then to self-organize. You can think about things like the Arab Spring. But however, in recent years, what's becoming clear is that there's a dark side to social media and social computing. Right. There's trolling, online harassment, and misinformation that's increasingly prevalent in many online platforms today. And even before the recent US presidential elections, chances are you've probably been thinking about what's going wrong with social media. Right? Why are there so many trolls in online discussions? Why do I sometimes feel unsafe when posting things online? And why is there so much misinformation? And it isn't just a feeling. Right? Antisocial behavior is commonplace. Right? A recent Pew Internet survey found that 4 out of 10 users online have been harassed. For example, being called offensive names or being sexually harassed. And you know that antisocial behavior is a problem when many popular websites are so overrun with trolls that these websites have just decided to completely turn off their comment systems. So is social media getting out of hand, and are online communities getting worse over time? And are we actually witnessing an epidemic of bad behavior? So ultimately, we do want to build better, healthier online communities to combat antisocial behavior. And there are several ways we could think about doing this. So first, we could try to create better guidelines for online conduct. We could design better interventions or develop better systems to combat such behavior. But to do this, first and foremost, we need to understand exactly what's going on. So what do we already know about antisocial behavior or trolling? So prior work has largely characterized trolls as a small vocal minority, and that antisocial behavior is due to sociopaths. So in qualitative interviews, trolls come across largely as very different from most of us, right? For example, taking immense pleasure in others' misfortune. And other work has also established trolls as having unique psychological profiles, being more Machiavellian or being more sadistic. But rather than it being innate and the domain of sociopaths, my work shows that antisocial behavior or trolling can be situational and that anyone can be driven to troll. So given this previous view of trolling, we might have concluded that simply removing the bad actors would just make all of our problems go away. But because trolling is kind of more or less situational, then we need a different perspective, and we need to ask a different set of questions to understand exactly what's going on and what we can do about it. So here are 3 questions that I'm going to try to answer in this talk. So first, we're going to look at why trolling occurs or the causes of antisocial behavior, or how anyone might become a troll. And next, we're going to look at how antisocial behavior might worsen over time or even spread from person to person. And last, we'll take a bird's eye view of antisocial behavior and spreading behavior more generally, and look at cascades and if they can be predicted. So how I do this is by complementing data mining with crowdsourcing. So I use data mining to find generalizable insights, and then combine this with crowdsourcing, which then enables online experimentation that can then establish causal links. And so while this talk focuses on antisocial behavior today, my work as a whole involves other aspects of both data mining and crowdsourcing. But on with the show. So let's start with the causes of antisocial behavior and ask if anyone can become a troll. So before I continue, as a heads up, some of the content examples in this talk may contain strong and offensive language, so do be warned. So in this work, we study antisocial behavior in the context of public commenting platforms, such as on CNN.com. So here's an article from a few years back that talks about how women perceive themselves online, and here are some of the actual comments on that article. So here's one of them. And here are the replies to that comment. So there's some name calling, some sarcasm, and it's mostly not very constructive. So to understand instances of antisocial behavior, like what I just showed you, in collaboration with Discuss, we analyzed a data set consisting of multiple large commenting communities. And so this data set we analyzed comprised of over 1 terabyte of complete data over a year of activity from over 76 million users who made a total of 470 million posts and 831 million votes. But before we can analyze trolling, we also need a working definition of what trolling is. So here are 4 different definitions of trolling. Is it engaging in negatively marked online behavior? Is it not following the rules? Is it taking pleasure in upsetting others? Or is it disrupting a group while staying undercover? So a lot of these make sense, and some of these are broader, some are more specific, some encode intent, some do not, and maybe your preconceptions of what a troll is may speak to even other definitions. So in this work, what we're interested in lies closer to bad behavior in general. So we take inspiration from some of these broader definitions and define trolling as behavior that occurs outside of community norms. So under this definition, regardless of intent, trolling happens as long as people are seen to behave as trolls. And why this is nice is that the community guidelines for many of the websites that we analyze are pretty similar. No name calling, no personal attacks, no profanity, no offensive material, and so on. And by looking at how moderators moderate these communities using these guidelines, we can then use these as signals to automatically identify who's trolling and who's not. But while trolls exist, we don't really know very much about who's responsible for this kind of bad behavior. And as prior work, as well as these headlines suggest, the media portrays trolls as this group of misfits that definitely are not any one of us in this room, but is this really the case? So what can looking at data tell us? So for instance, if trolling is innate, are trolls just trolling more often than not? So here's a plot showing the distribution of users who were banned from CNN.com, which we use kind of as a proxy for trolling behavior. And we might imagine that if trolls are inherently bad, that they might have most, if not all, of their posts deleted by moderators. But while many of the supposed trolls do have all of their posts deleted, a sizable number also have a much smaller proportion of those posts deleted as well. So in other words, the distribution of trolls or people who are banned is bimodal. And so could these 2 peaks correspond to 2 different types of antisocial behavior that goes on? So maybe the people who are writing bad content all the time are these lifelong regular trolls, and those who only had a smaller fraction of these posts deleted, maybe they're just having a bad day. And importantly, because we are looking at just banned users, we are underestimating this proportion of situational trolling. And also now, because of these observations, we started to reconsider our assumptions that trolls are just a vocal minority. So rather than trolling being mostly innate, was there a question? Yeah.
On the previous graph, is there some threshold for number of posts per user here?
Yep. So we are looking at people who made at least 10 posts, and so that's our threshold here right now. Yep. Thanks. So rather than trolling being mostly innate, what if antisocial behavior is actually more situational? So, but of course, how would you even go about showing whether this is true or not? So we can make observations with data, but it's hard to demonstrate exactly what causes trolling. And if we did run an experiment, the issue might be that it won't generalize. So our solution was to combine both, to conduct an online experiment simulating a discussion, as well as carry out an observational study of an actual discussion community. So while the experiment helps us establish causality, data analysis lets us demonstrate replicability, as well as generalizability. So now I'm going to claim that anyone could become a troll, and using evidence from experiments and data, I'm going to show you how it's possible to induce people to troll, and I'm going to do so by drawing on theories from social psychology first. So the first is the broken windows theory, which suggests that norms can strongly signal whether further bad behavior happens. So for instance, that broken windows signal that crime was acceptable in the neighborhood. So the second theory concerns how unpleasant stimuli, aversives, increase aggression. So one study showed how exposure to secondhand smoke increased a person's aggression towards other unrelated people. But still, much of this prior work was conducted decades ago in the absence of online interactions and under different circumstances. So could this actually translate into trolling online? So to begin, we first conducted an experiment on Mechanical Turk that simulated a discussion forum. So the general structure of the experiment was as follows. So we had participants take a quiz, and then we had them participate in an online discussion. So varying the studying conditions, we ran many identical discussions in parallel to observe how participants' behavior changed. So in this experiment, we used a 2x2 between subjects vectorial design, where we modified the difficulty of the quiz as well as the initial discussion context. So drawing on theories of aggression, we varied the difficulty of the quiz to influence participants' mood, and drawing on the broken windows theory, we varied whether the discussion context was good or bad. So what did the quiz look like? So the quiz that we asked participants to take looked like this and had 15 questions. So the version in a positive mood condition was calibrated to be pretty easy, like so that participants would get high scores and feel good about themselves. So the other version of the quiz was substantially more difficult and designed so that most participants would score poorly instead. And in this version, regardless of how they actually performed, we told users that they did poorly anyway. And lastly, participants had 5 minutes to complete all of these questions. So after completing the test, we then had participants take part in discussion about the then upcoming US presidential elections. So for some context here, the experiment was done during the 2016 Democratic primaries, where people were deciding whether to choose Hillary Clinton or Bernie Sanders as the Democratic Party's presidential candidate. So in the positive discussion context condition, we see the discussions with initially more neutral and more constructive comments, such as these. And in the negative discussion context condition, these seed comments were more negative. And again, these are all real comments. So first, what happened, right? So first as a manipulation check for mood, using a post-quiz validated mood questionnaire, we found that people were in a much worse mood after the hard quiz than the easy quiz. And people also naturally got worse scores on the hard quiz as well. And as a check for discussion context, we also found that initial seed posts in the negative discussion context condition were also perceived as worse. So they were only 36% upvoted compared to those in the positive context condition, which were 90% upvoted. So now on to our main result. So how much trolling was there in each condition? So here we had 2 expert raters label posts as trolling or not blind to condition, and they were using standard community guidelines, such as those from CNN.com. So we then measured what proportion of posts made in each condition were troll posts. So the participants were in the positive mood context condition, or that they saw the easy quiz and discussion without any troll posts. The rate of trolling was lowest at 35%. Now, this number might seem high, but also remember that participants were commenting on a relatively controversial topic at the time. So if people got the difficult quiz or were shown troll posts previously, the rate of trolling increases in both cases by a similar amount. And if people got both the difficult quiz and were shown troll posts, this led to almost twice the incidence of trolling. And so we tested the significance of these results using a mixed effects logistic regression model and found that both main effects were significant and that there were no significant interaction effects. So we could analyze our data a different way, and now we use Luke to measure the proportion of negative emotion words as a proxy for trolling behavior. And so what we find is a similar trend to the proportion of negative emotion words almost tripling in the worst condition compared to the base positive condition. And so to give you a sense of what participants actually wrote, so here are 2 examples. So here's one comment from the good condition, right? When participants did the easy quiz and were shown neutral comments. So like this one, the majority of them were pretty reasonable. And on the other hand, when people were in a bad mood and or had seen prior troll posts, they wrote things such as this. So in other words, bad mood and negative discussion context increase trolling. But now you might say that this is only a lab experiment, so these results might not hold up in the real world. So what we did is also analyze an actual discussion community, CNN.com, to see if we could try to replicate our findings. So turning to data, here's what we found in relation to both mood and discussion contexts. So now, while we can't study mood directly from data, we can study its correlates. So for example, prior work measured how mood tends to swing with the time of day and day of week, and we found remarkably stable patterns, and they found remarkably stable patterns in how negative affect or the amount of negative words used on Twitter changed with time. So if we could observe similar trends with regards to indicators of trolling, that would be highly suggestive of mood influencing that as well. So here's a plot with the time of day on the x-axis and the proportion of flagged posts on the y-axis. And so what we find is that a post made in the morning, it's much less likely to be flagged for abuse than one made in the evening. And what's nice is that this matches prior results and findings on how negative affect changes with the time of day. Similarly, there are changes based on the work week as well. So post flagging or trolling is highest at the beginning of the week and decreases as we near the weekend. And we didn't just observe this for the proportion of flagged posts. So across multiple indicators of trolling increases at the times of day and days of week when people are in worse moods. We also find that anger can lead to more anger. So just as we found that doing poorly on the quiz affected later commenting and discussion, negative mood spills over from prior discussions into subsequent unrelated ones. So to show this, we looked at discussions with at least one flagged post and selected a user who was flagged and a user who wasn't at random. And so that we aren't selecting people who are already trolls, we ensure that both users never had any of their posts flagged or deleted in the past. So now when each user goes on to post in a separate discussion, we then compare the likelihood of that future post being flagged as well. And what we find is that users who were previously flagged were also more likely to be flagged in later discussions. So in other words, if we compare users who were trolling in previous discussions with those who were not, we find that those who did troll were twice as likely to troll in unrelated discussions. So turning to the discussion context, we can also directly replicate our experimental findings here and show that the initial post in a discussion strongly affects the subsequent likelihood of trolling. So here we compare two top-level discussions of the same article, where one begins with a flagged post and one does not. You find that discussions that begin with flagged posts are more likely to have subsequent posts flagged as well, and that here the control for confound excluded the OP as well as users flagged or deleted in the past as well. So in fact here, initial troll post increases the rate of trolling in subsequent posts by 63%. So that was context. Now having established factors relating to trolling experiment and in data, as a next step, can we predict trolling before it happens? So here we examine the balanced data set of 120,000 posts so that random guessing results in 50% accuracy. We then train a logistic regression classifier in the following sets of features. So mood, discussion context, and user features. So you can measure mood indirectly through flagging in previous discussions and also with diurnal changes. And we can measure context just by looking at prior posts in the same discussion. And the third set of features is just based on an indicator variable for every user. So these features kind of let us test the relative importance of two different hypotheses, but whether trolling is more situational or if it's more innate. So here's what we found. So we just identified trolling behavior. By finding supposed trolls, you do kind of okay. So you get about 0.66 AUC. But when looking at mood and context, we can do a little better. So mood alone actually does worse, but this is expected because we can never observe mood directly. But however, a discussion's context does outperform using user-specific features, showing that extrinsic factors such as discussion's context are more important than intrinsic user-specific features in predicting trolling. And of course, if we combine all the features, we can do even better at predicting the subsequent post will be a troll post, even without looking at the content of the post. Yes?
I'm a little confused by the setup to understand how, how the results are affected by the fact that it's only when they post again. So someone who really doesn't like negative context and trolling type posts might choose not to post in such a thread.
Yep, I think that's a good point as well. So again, here we are looking at people who do decide to post afterwards, and definitely there can be effects of whether you post or not. I'm actually going to cover this a little bit later in the talk as well. But again, happy to talk about this afterwards too. So to summarize, we might think about two factors that influence a user to troll. So first, their mood sets a baseline for how susceptible they are to trolling. And when a user participates in a discussion, posts written by other users provide the spark or impetus to the user and directly results in them trolling or not. And so to end this section, because trolling is more situational than innate, anyone can become a troll under the right or wrong circumstances. So now we might be thinking, so what could we do to mitigate bad behavior? So could voting be the answer? So voting is present in a lot of social media websites, with one popular example being Reddit. And the concept behind voting is simple. Better content should get more upvotes, and worse content should get more downvotes. But does this actually work in practice? So here's another claim. So instead of voting helping to reduce bad behavior, we can show that it instead exacerbates the problem, because downvoting can cause negative behavior to worsen. And so this is the next question we're going to ask: how antisocial behavior might worsen over time. And so in other words, could such behavior spiral? So in this section, we're going to look at the role voting has and how people get from bad to worse. So as votes are essentially a way for people to evaluate other people's content, we subsequently describe them as evaluations. So here our goal is to see how people might react to not only negative but positive evaluations, so that we can compare the differences. So what do we mean by positive and negative evaluations? So here's an actual comment that got 5 upvotes and 4 downvotes. And together, these numbers can help us quantify how positive and negative an evaluation is. So in this work, we define a positively evaluated post as one where the proportion of upvotes is greater than some given threshold, say the 75th percentile post in terms of the proportion of upvotes. And similarly, a negatively evaluated post is one where the proportion of upvotes is lower than some given threshold, say the 25th percentile. So given that a user received a positive or negative evaluation from other members of the community, how will that user's behavior change afterwards? So theory suggests that either is possible. So operant conditioning says that feedback guides authors towards better behavior, so that users would behave better after getting either a negative or positive evaluation. So an upvote means that you did well, and a downvote means that you didn't and should improve in the future. So on the other hand, bad is stronger than good. Bad impressions are quicker to form and more resistant to disconfirmation. And people have a much better memory for when bad things happen than when good things happen. So which is it? So to answer this question, we focused on 4 large commenting communities, and the results here I'll show apply to all of them. And so there's CNN, IGN, a gaming website, one in the middle which you might recognize, and All K-pop, which was a K-pop website. So say we have 2 users, one positively evaluated and one negatively evaluated. So if you look at these users' posting histories, one important question we're going to ask is how either user's posts are evaluated before and after that middle positive or negative evaluation. But of course, simply comparing 2 different users isn't going to work, because who's to say that people who got downvoted aren't inherently worse commenters? So downvoted comment might also be inherently worse as well. So how might we go about solving this? So what we do is instead to conduct an observational study using what's called propensity score matching. So the general idea here is that we want to match pairs of users that have been up to the point of comparison as similar as possible, and that we see what happens after they receive different treatments, right? In our case, either positive or negative evaluation. So again, here are 2 users, one positively evaluated and one negatively evaluated. And of course, these 2 users are not going to be writing the same thing, but we want to ensure that they are as far as we can. So what we do is first match pairs of users on text quality, which essentially turns text into a comparable number. But of course, what on earth is text quality? So here's how we compute it. So what we did is train a machine learning model that only uses bigram text features of a post content to learn the proportion of upvotes P that it received. And then we predict, we define the predicted proportion of upvotes as text quality Q of this post, and we can obtain Q just by looking at the text of the post. So you might be concerned with bias in computing text quality, since the proportion of upvotes itself may be biased, but are hopefully already doing reasonably well by using only text as our features. So as an additional check, what we did was we crowdsourced labels for whether a post was good or bad using standard community guidelines for a subset of posts where 10 crowd workers labeled each post. And from this, we can obtain Q prime, or the true label of text quality, or how good or how bad something is. And to see how good Q is compared to P, we can correlate Q prime with both P and Q. And so here's what we found. So we find that text quality is far more correlated with the crowd's guess than the actual proportion of upvotes is. And what this is saying is that text quality Q is a reasonable, but again, nonetheless noisy approximation of Q prime, the crowd's guess. So you can observe that the error between Q and Q prime is also distributed relatively randomly for different values of Q, so there's no systemic bias in using Q to estimate Q prime. So back to the problem. So say to match pairs of users, we first ensure that these two posts have similar text quality. And we also control for the length of the post the number of words. We further made sure that these users' complete posting histories were similar as well before this positive or negative evaluation. For example, ensuring that they had a similar number of posts and similar proportion of upvotes received on their post prior. So after controlling for these factors, we now have matched two users that are basically indistinguishable from one another on our match covariates. Not only one got a positive evaluation, and while another one got a negative evaluation. And as a quick aside, here's how we actually do this. So we identify covariates we want to control for, including text quality, number of prior posts, and we identify our outcome variable of interest, which could be text quality of the posts that follow. And to control for these covariates, we then estimate the propensity of whether a user is likely to be assigned to each of these treatment conditions, and finally use these estimated scores to compute optimal pair matching using an algorithm of choice. So for replicability, we also try and matching directly using coarse and exact matching with empirically similar results. So after controlling for our covariates, how should we measure how subsequent posts are evaluated? So other than text quality, as I mentioned earlier, how else might we measure changes in evaluation? To answer this question, we also need to understand what an evaluation is made up of. So essentially, there are two components to an evaluation. When you evaluate something that someone wrote, both the something, the person, the something, the content, and the someone, your preconceptions of that person, they both reflect what you evaluate. So the first component are textual effects, or text quality, or how well people write. So in other words, was a post downvoted because it was badly written? The second component relates to community effects, or how community perceive that particular user. So does a person get downvoted regardless of what they post because the community just simply dislikes them now? So to start, let's first look at the first component of the evaluation relating to the text of the post and ask if people write better or worse after a positive or negative evaluation, having controlled for our covariates such as text quality prior. So using a sign rank test, we find that post quality drops significantly after a negative evaluation, but not after a positive evaluation, and this is true in all the communities that we studied. So this change only after a negative evaluation kind of echoes findings on the positive-negative asymmetry effect from social psychology, and the intuition here is that you feel a lot worse after getting a negative evaluation, but not a lot better after getting a positive one. So people write worse after receiving a negative evaluation. Let's look now at how community perception changes after these positive and negative evaluations. So for example, after receiving a negative evaluation, does community perception worsen? So, but of course I haven't showed you how we actually compute community bias. And for each post in our data set, we have the number of upvotes, number of downvotes, as well as text quality, all scaled to be between 0 and 1. And comparing the actual evaluations with the predicted text quality, we can then see if a community is positively or negatively biased. So what do we find? So what we find here is kind of a halo effect. Posts made after a negative evaluation were perceived worse than we expect, but not after a positive evaluation. So in other words, the community is predisposed to downvote you if you've been downvoted in the past, regardless of what you write. And on CNN, your post on average being evaluated 30 percentage points worse than would be predicted by text quality. So to visualize all of these findings so far, so say we have two posts by two users, one positively evaluated and one negatively evaluated, with the y-axis signifying how positive a post is. First, we can control for the text quality of these two posts. And next, we also ensure that the users who wrote these posts have similar posting histories. If you then look at what happens to text quality after this positive or negative evaluation, you find that text quality drops after a negative evaluation, but not after a positive one. And if you further compare the changes in community bias, or the perceptions of these posts, we find that perception worsens after negative evaluation beyond what text quality indicates. So in summary, here's what happens to negatively evaluated users. So not only do negatively evaluated users write worse posts after, but these posts are also perceived worse by the community, and there's more bad news. So you hope that maybe negative feedback discourages people from posting. But however, people who are negatively evaluated are also more likely to post more frequently than those who are positively evaluated. And also, they are more likely to evaluate others more negatively as well. So they retaliate to being downvoted by downvoting others. So let's update our model of trolling. So mood as well as context through what other people write can cause people to troll. But beyond just writing, downvoting also makes things worse. And bad behavior can actually feed back into the system, as people who get downvoted or trolled are more likely to troll and downvote others as well, resulting in this kind of negative spiral. So what this really means is that a troll might have started out as an ordinary user, but that got downvoted, started to write worse and be perceived worse, and also never really recovered after that. So given that antisocial behavior can spread from person to person, on a macro level, can we actually observe this downward spiral in these communities? So as some food for thought, so here's a slide on how the proportion of upvotes given on CNN is changing over time. So on the x-axis here is time, so this is from 2012 to 2013, and we note that it starts out higher, but is gradually decreasing over time. So if you leave negative behavior unchecked in the community, it can have far-reaching effects in the long term and cause the community to worsen over time. And now more work definitely needs to be done here, but overall it's interesting to see how these microscopic interactions between individuals might translate into macroscopic observations. So at this point I've talked about antisocial behavior and how it might spread from person to person, but what I haven't talked about is what's going on at the macro level. So how is bad behavior and bad information more generally spreading in these networks, and is that spread predictable? So popping up one level, in this section, we now turn to what's going to happen when bad things cascade. So beyond bad behavior, something that's also been getting a lot of attention recently is bad content, or more generally, rumors. So rumors don't only come in the form of fake news. So once in a while, you see these image memes make the rounds, and you might wonder why these things keep appearing. And however, like when we are studying these rumors, something we noticed commonly was that these rumors can have wildly differing levels of popularity. So here are two examples of people sharing the same rumor from before, but why did one get no reshares, and well, the other got 416? And so what's worrying here as well is that the one on the right that got 416 reshares, in the comments for this one, many of them called this article, this comment out as fake. So really what's going on? So rather than focusing on the rumor itself, perhaps you can learn more from understanding the underlying network in which rumors, misinformation, and fake news propagate. So if we analyze the cascade that makes up the spread of a rumor, we can now ask the broader question of whether these cascades are predictable and whether our findings can then be applied to both rumor cascades as well as the spread of other information cascades as well. So for some background as to what a cascade is, here's a friendship network with edges connecting friends, and suppose I share a rumor. So maybe two of my friends decide to share it as well. Two more people see this rumor shared by one of my friends and shares it themselves, and as more and more people share this rumor, a cascade is formed. Here you can highlight that in gray. So though we want to predict how a cascade grows, there is evidence that these cascades may be inherently unpredictable, and there are several compelling reasons why this might be. So first is that large cascades are rare. So shown here is the distribution of the size of reshare cascades on Facebook from 2013. And as you can see here, the number of cascades that actually gets large is vanishingly small. So less than 10% of cascades reach 100 reshares. So because large cascades are so rare, it might be hard to predict when they actually occur. So past research also provides more evidence. So in the famous Music Lab experiment, participants use a music ranking service to rate songs, and the goal is to see which songs will become more popular when the experiment was repeated multiple times. And so what the study found was that it was hard to predict which songs would get popular in each instance of the experiment. In other words, that increasing the strength of social influence increased both inequality and unpredictability of success. So this suggests that it might be difficult, if not hopeless, to predict whether something will become popular or if a cascade will grow large. So another thing that also makes cascades unpredictable is that they can die down and then resurface or recur after long periods of time. So in contrast to prior work and perhaps our intuitions, what I want to show here is that cascades are actually predictable. So not only can we predict the cascade's future size, we can also predict how its structure will change and how identical pieces of content can be differentiated. And we can also predict if they will come back in the future. So let's begin with the task of formulating the prediction problem of predicting the growth of a cascade. So given that we have some number of reshares, how should we predict its future growth? And so there are several possibilities here for how we might formulate this problem. So maybe we could ask if a cascade will get a large number of reshares, or maybe you could try to use regression to predict how large a small cascade will get. Or perhaps you can try to look only at the large cascades and compare them with random other cascades. But each of these has different problems. So there are issues in terms of the size of each class, the distribution of data, and how the data was selected in the first place. So how do we formulate a task that doesn't suffer from these issues? So what if we instead ask if the cascade will reach the median size, and by definition, the median splits the data set 50-50, so we have a balanced classification task. So now you might also ask, what is the median, say, f of k? And perhaps more intuitively, the question of whether a cascade will reach the median size is equivalently a question of whether it will double. And this follows because the size of a cascade tends to follow a power law distribution with exponent of 2. So to formally define the cascade growth prediction problem, we ask, given that a cascade has obtained k reshares, will it double in size? And what's good about this approach is that it results in a balanced prediction task and allows us to track the growth over time by varying k. So over 28 days, we sampled over 70 million public photos uploaded to Facebook, resulting in 5 billion reshares, and tracked reshares of these photos over 28 days following their initial uploads. So we looked at 4 different sets of features. Content features, so whether it had overlaid text or not, whether it looked like a meme or not. We looked at user features like friend count. We looked at structural features like the proximity to the root node, because cascades are basically directed acyclic graphs, so we can start to understand them that way. And we also looked at temporal features, so how fast is something being shared. And so what we find is that we can predict cascade growth reasonably well. So again, using a logistic regression classifier to predict if a cascade that reached 5 reshares would double in size, again, we find that performance is robust, independent of feature sets. So even without these temporal features, which do best on their own, we don't lose too much in accuracy. So cascade growth is predictable at least for 5 reshares. But what if the number of reshares we observe increases? So what happens to predictability as we observe more of the cascade? So how does prediction performance change as k, the number of reshares, increases? So is it easier or more difficult to predict whether a cascade with 5 reshares will grow to 10 reshares, or if a cascade with 10 reshares will then grow to beyond 20 reshares? So on one hand, maybe you have more data in the second task, so the second one is easier. But on the other hand, the second question is also a harder, more complex question, and you have to predict further into the future as well. So which is it? So what we find is that as a cascade grows larger, it becomes easier to predict when it will double. And these results demonstrate that observing more of a cascade while predicting further into the future is easier than observing a cascade early in its life and predicting what it will do next. So again, what's nice about this approach is that it lets us continue to ask, as the cascade continues to grow from small to large, whether it's going to continue doubling in size.
Sorry, what were the features again you were using to predict the doubling?
Let's see. So these sorts of features, right? If you're interested in the specific ones that we use, you can look up the paper that this work is based on, and we have a whole list of them.
I have a question.
Yeah.
So trying to understand the data size. So how many
Cascades got up to 100 people?
How many cascades got up to 100 people? Yeah, so again, these data sets are going to get smaller and smaller as you kind of condition on like how large they have to be at the start. So if you have like 100, you get to like maybe like tens of thousands instead of like millions of cascades. So, but still enough to do this prediction task.
Are you retraining the model at each K, or is this the same model being applied regardless of the?
So it's a different model, trained at each K, and we also looked at like how the different features perform differently as well, depending. I know that's I guess that's out of scope of this talk, but also happy to talk about that afterwards as well. We have
binary question, do the features shift across?
Yeah, they definitely do shift across. Let me see, I think I have some slides for that here. Or maybe I do not. But anyway, yeah, I mean, you have things like what we find is that like features relating to the root cascade become less important as the cascade grows larger, right? So whatever you're posting becomes less important once the cascade has reached some kind of size, and then the structure of the cascade tends to matter more as it grows larger. So again, you have this like shift in how features, the relative importance of different features as the cascade grows. Yeah. So, but not only is cascade growth predictable, so for instance, we can also predict if a cascade will be structurally more or less viral, or if a cascade will recur or come back. So if this is the individual view of antisocial behavior from before, this might be how the network view looks like, where posts, comments, votes, and rumors are transmitted from person to person, and also result in long-range, far-reaching cascades in the network. So to conclude, so here's an overall summary of what we found. So we found that trolling is situational, and that a person's mood and the context of a discussion can influence them to troll, meaning that ordinary users can end up trolling in the right or wrong circumstances. So further, we found that trolling behavior can spread, not only through these effects, but through negative evaluations or downvoting as well. And finally, looking more globally, studying cascades of bad behavior and misinformation, we also looked at the spread of rumors and of cascade and find that, contrary to prior belief that they're fundamentally unpredictable, that the spread can be predicted. So as I mentioned previously, this plot on how the proportion of upvotes is decreasing over time is really interesting and something where more research is needed. So as these observations are they due to cascades or are they due to different changing populations? So more generally, how could we predict the trajectory of a cascade, of a community moving forward? So will the community, how will it eventually decline and how long will this take? But overall, like given these results I presented about antisocial behavior and this talk about studying the demise of communities, it might be easy to feel cynicism and despair about the state of social media or social computing. But noting more about the mechanisms of antisocial behavior, something I want to focus on is also on building better systems that deal with such behavior and instead encourage pro-social ones. So for example, here's an example of how a context-aware discussion platform that uses machine learning interventions could encourage pro-social behavior and how that might work. And depending on when a user might be likely to troll, different interventions might be useful. For example, if we think that a user may be angry in the heat of the moment, we could delay posts for some time. So what I've covered today is a small slice of the work that I've done in data mining and crowdsourcing, which has included large-scale analyses, experimentation, as well as system building. And if you're interested in any of these topics, I'm happy to talk about them afterwards as well. So thinking a bit more broadly, what I hope to accomplish in my research is to develop holistic end-to-end approaches to better understanding social systems. So by combining large-scale analyses with experimentation, I hope to make generalizable observations that are backed by experiments which establish causality and enable prediction. So for example, I might work on predicting the causes of trolling. So I hope to also look at both the big picture interactions in networks and relate them to those between individuals. For example, in relating network theoretic properties of cascades to the mechanisms through which they propagate. And importantly, my research seeks to leverage these findings to develop new systems that better support our online interactions, for example, by building pro-social discussion platforms. So as a whole, my research shows how much multi-methods analyses allow us to identify patterns in data, verify hypotheses, make predictions, and develop social systems. And using such an approach, my work has contributed to the understanding of antisocial behavior as well as cascading behavior more generally. So in the future, I hope to continue creating new methods, tools, and platforms that further improve how we use technology to interact with one another. So I'd like to acknowledge my advisors and mentors who have helped me immensely on my journey towards a PhD, as well as my collaborators, colleagues, and the institutions that have helped, supported, and continue to support me in my research. So thank you for listening, and I'll take any questions now.
I'd like to make sure the first question is not mean-spirited.
Yes?
So in a number of online posting forums, you had political posts, for example, but there are also sports-related posts. What might be considered a not necessarily trolling behavior, but a strongly negatively downvoted post might vary on context. So what's on the on an article about the New England Patriots might be different from an article about the Seahawks or something like that. And you had politics as another sort of team-based thing. Did you distinguish anything or find anything about the differences in situations where you have those polarized views versus sort of more vanilla type topics?
Yeah, so definitely I think even like understanding like different teams and how that might play a role in trolling, that's interesting. So what we did is we actually like looked at the different topics on CNN as well, right? To see how trolling might differ depending on whether you're talking about politics, whether you're talking about sports, or science and health, or opinion, right? And what we find is that trolling does differ. So the baseline rates of trolling are going to change as well depending on which communities you are, or which sub-communities or subtopics that you're looking at as well. And also what we did here is also try not to define in terms of how we might imagine what trolling is, but to look at what community moderators do, right? So they kind of give us the ground truth for what is trolling and what is not. Obviously, again, we want to do better in the future as well. We think this is a good first step in identifying what's good behavior and what's bad behavior. But obviously, there are many different types of bad behaviors as well. And there are lots of different factors play into different types of them happening, right? Whether it's like something that's more extreme or something that's just like very, very downvoted, or something that's more controversial versus something that's just swearing, right? So I think all of these things are interesting directions to pursue in the future. Yeah.
Thanks. I'd like to understand how the cascade prediction fits into the broader context of network theory. So what are the unique aspects of the cascade prediction to antisocial computing? Could we take the prediction and use this to predict how financial speculation could lead to global stock market shifts? Could we use it on tweets around the time of the Arab Spring and predict massive events in the real world? What are the aspects unique to antisocial computing that you used here, or is there a generalization?
I think that these methods, especially with regards to cascades, these are a lot more generalizable. I think here, like we're just looking at here are these techniques that we can use. Here are these features that are important on Facebook. So not only for these negative cascades, but for cascades in general as well. So again, like we can use these kinds of methodologies. We're going to be identifying different sets of features as well for different platforms, say versus Facebook versus Twitter. And I think they're like depending on like what is interesting, what we want to study, we can train specific models that are more fine-tuned and fine-tuned to like specific things they're looking at. Like if we're looking at rumors, we're going to identify like which things are rumors and which ones are not, and we can use this by looking at Snopes.com, and also like to try to find like what are specific features of this cascade that we're interested in, right? And also that's going to kind of affect kind of more broadly like how these things spread, like whether they spread through strong ties or weak ties, and we have some upcoming research on that as well. So again, like good question. I think we can think about how we can apply this a lot more broadly than just to kind of even just cascades on Facebook, but just anywhere you might see information spreading from person to person. Yes. Oh, middle person.
Regarding negative feedback, would it be interesting to see on posts with similar amounts of negative feedback, if you hide some of the negative feedback from the poster, would that affect future negative behavior?
Okay, so the question was on whether hiding negative feedback might kind of promote like future like good behavior. I think that's definitely like something that we want to be testing. So some of our future work is actually trying to look at the effects of introducing downvoting into a community. So we have like kind of this natural experiment where we can look at like what's the effect of like introducing an ability to like kind of downvote others, right? And also we can think about experiments where we actually just remove this, right? And I think this kind of work is a good argument for why we don't actually want downvoting in a lot of places as well, and that maybe we want different venues in order to like do the kind of ranking that we need to do, right? So maybe different types of feedback are necessary, right? And kind of minimizing the ones that kind of make you feel bad as a person. Yeah.
So one of the things that you kind of didn't talk a lot about and treated as more or less exogenous and fixed is the community standards and how they're applied. So it's quite possible, I can imagine, that a community outlines, or the web, it's not necessarily a community, it's really like CNN or Breitbart, defines its standards. Hopefully they're fixed over the period of your study, but the way they're implemented is totally opaque to us, right? So presumably there are moderators, maybe their standards shift over time, maybe they make strategic policy changes, maybe all kinds of things are happening. Do you have any sense that you can trust these things are stable and therefore that the thing you're measuring is really a thing?
So there are a couple of ways we try to like kind of go about doing this, right? So firstly as well is that we think that like in contrast to just trying to arbitrarily like define like what trolling is, right? Independent of what the community is, we think that this is a good way to get like kind of labels at scale. But of course, like you mentioned, we might not be trusting these labels. So what we did is also we kind of used these guidelines as well, and then we kind of manually labeled a subset of them using crowdsourcing as well, and we kind of compared them and correlated them with actual like post deletions or actual flagging to try to figure out like are these like good indicators of whether this flagging behavior is kind of correlated with like what these guidelines say is bad behavior. And what we find is that is the case. Again, I think there's interesting things to think about, like how that might be changing over time as well, although I imagine that that's going to be a smaller factor. Again, the other thing that we did was also do the experiment so that we kind of get around this like community, kind of this fuzzy concept of like what community norms are. So again, like I guess there are these different ways that we can try to triangulate whether some content is good or bad. I think there are a lot of these interesting questions about how these things might change and evolve over time as well. And happy to explore them in the future. Yeah.
So far your work has focused on explaining and predicting negative behaviors online. Can you speculate how you would go about actually affecting online behavior, how you would change a platform to lead to better discussions?
Right, so I think there are many different ways that you might do this, right? So there are two like main approaches, right? One is to identify like how we might redesign like these platforms, right? How might we redesign discussions more generally? Like, do we like slow down discussions so to make people like feel less angry over time? We can tell that they are. Can we do like prediction? Can we add elements of NLP into these kinds of models to identify like when argumentation takes place? Try to figure out when unsubstantiated claims are taking place. So I guess we can like, kind of think about these two kind of main approaches towards like trying to improve these discussions. Yeah.
I had a question about the cascade effect. So this is very interesting conclusions. Part of me still thinks the straw man is that cascades are sort of hard to create from a causal perspective. So while you have a predictive model, there's kind of a question of, how does this relate to causality? And for example, one could easily think of a network model where the state of the network is very predictive of the way it'll spread, but that doesn't mean you could actually easily create a cascade, or maybe you could by buying certain people to redisplay certain posts.
Yeah, I think that's very interesting, like to think about how you might like develop like causal models of like cascading behavior. I think this is definitely like one area I want to be thinking more about. So I think I'm thinking about like how might we design experiments where we can try to kind of have these like multi-step like kind of interactions, right? Where one person affects another person affects that. I think we might need like new techniques in like crowdsourcing and like experimental design to kind of figure out like how you might trace these effects and how they change over time. I think in terms of just looking at data as well, I think there are opportunities to kind of do kind of quasi-experimental studies as well. So again, like there are cases where like maybe the same content appears in different part of the network at about the same time, and where like properties of the network in different places are kind of similar. So we could try to do that, try to control for it that kind of way, and try to understand like if we like vary one of these like covariates, like what's going to happen moving forward. But yeah, I think these are very hard but still very interesting future directions.
Maybe one last question.
Yeah.
So in your first set of experiments, I guess seeing those experiments in the data, like the hypothesis that I would think that you would come up with was like, you know, there are some people who will troll and some of them will only troll when they're in a bad mood. Do you feel like that was ruled out and so you went with like anyone can troll?
So I guess again, like maybe the more accurate term to say is that ordinary people can troll. They're going to be like these people who are bad all the time. They're definitely going to be the people who are good all the time. But then there's this like whole range of people in the middle where they kind of like could be swayed in one direction or not. Obviously, I'm not saying that anyone can become a troll, but it's more like if we think about it, like ordinary people like you and I, depending on whether we're in a good mood or a bad mood, on average, we can like behave badly, right? In certain situations, right? And even if that's happening kind of not very commonly, like because these things can kind of like spark like other people also behaving badly, like even just a little bit of it at the start can kind of cause these like cascades of bad behavior to happen.
Great. Why don't we thank our speaker again?